what we would do tonight is just go through a little bit of the cubic function, just because it is such an important part of paper 1. And if you've got any sort of other general questions that you maybe wanted to ask about, then we'll see if we can fit that in too. So this particular question is something that I haven't yet had a chance to do with you. I wanted to do it when we did the course on cubic functions, but we didn't get round to it. Okay, so this is a very typical cubic function sort of question. They've given us the graph of g of x. It is the graph of x cubed plus bx squared plus cx plus d, and it's been sketched. And the graph of g intersects the x-axis at -5, so that's been drawn for us, and at p, and the y-axis at 20. So p and r are the turning points. And they want us to show that B is 1, C is -16, and D is 20. Okay, so that's, I wouldn't say fairly difficult, but it's not a straightforward question, all right, to start off with. Do you think you know how to do that yourselves? Can you try that on your own? Or do you need help to get started? You want to try it on your own. Okay, all right. So we'll be quiet. You guys give this a bash. And if you are horribly lost and stuck, please don't just sit there and be quiet. Please reach out to us and we can help you. Okay, give it a try.
Sorry.
Yes, yes.
Personally, I have like an issue with cubic functions. Basically,
okay.
I'm also finding the equation. So I'm tapped out, to be honest.
Okay, that's fine. Okay, so in that case, everybody continue working. What I'm going to do here, Cornelia, is I'm going to give you a little bit of a sort of a head start. Okay, so we've got that over there. Sorry, I know it's a bit irritating having to go up and down and up and down and up and down. I'm so sorry. I don't know how we get away from that with this online stuff, but anyway. Okay, so Cornelia, when you are working with the equation of a cubic function, you need to work with it in the form y equals a x minus x1, x minus x2, x minus x3. Okay, that's when we've got 3 distinct, separate intercepts. But in this particular graph, how many x-intercepts do we have? Exactly, we've got 2, all right? So what happens when one of the turning points, what happens in our equation when one of our turning points is also an x-intercept? How does that change things? What do we see happening? That's it, can you see? One's also the turning point. So how does it change this that I'm highlighting in yellow? Doesn't change it very much, but there's just one specific thing that it changes. Can anybody tell me what that is?
Ma'am, it becomes a squid.
There we go. Well done. Okay, quite right, Kanyisile and Hope and Mr. Bavuma, quite right. So we've got a bracket that is now going to be squared. So in other words, we've still got y equals a x minus x1, but x2 and x3 are equal roots. Okay, so that's why here we would say x minus x2, and that bracket is the one that's going to be squared. Lovely. Okay, now what you need to do is go and substitute in the information that you have been given. You've got to work out the value of a first. So what they have told you over here is that when x is 0, y is 20. So when x is 0, y is 20. Okay. This minus x1, that is our first root. So here we're going to put in plus 5 because minus -5 means we're going to end up with plus 5. And over here we can call it x2, or we can call it p, or you can call it whatever you want. All right, if you want me to call it x2, I can do that. Hang on a second. That is not what that is. Am I just being silly here?
Don't you have to substitute
Yeah,
this?
because yeah, so we would need to, yeah, so we first need to work out, hang on a second, this is why I'm being silly, because, wait a moment, they've told us what A is equal to, beg your pardon, sorry, this is with us going up and down and up and down and up and down. Okay, so because we can't work out two unknowns in one equation. So if we have a look over here, all right, they have told us that A is equal to 1. All right, so we don't need to work out this A, we know that it's equal to 1. All right, there we go. All right, sorry, just going up and down and up and down and up and down. Okay, Tyler, does the squared have to be the last two brackets? No, it doesn't. If you want to put 0 minus x squared in the middle, you can do that as well. Okay, but what's important is that at that point, you've got equal roots. Okay, and that's why it has to be squared. Okay, so what we're going to end up with now is 20 is equal to 5 times, okay, so it's going to be 5 times x2 all squared. That's a little bit confusing. What I think we should do here, instead of using x2, is let's just use the letter p. Okay, and then there can be no confusion. Okay, and then that p is going to be squared. Divide both sides by 5, and p squared is going to be equal to 4. And now we can work out what p is going to be equal to, right? And in this case, it's going to be equal to 2 because it's on the positive x-axis. All right, so we would choose the positive answer. Does that make sense to everybody? Okay, all right. And now that we know that that's 2, now we can go back and go and sub in and say y equals x plus 5 times x plus 2 squared. So now if I wrote that like this, if I wrote it as y equals x squared times x plus 5, Tyler, it doesn't make any difference. Okay, it doesn't make any difference to how I'm going to work out my answer. What I need to do now is multiply out all my brackets. Okay, so now that I've spoken about the first beginning bit, you guys do the rest. You multiply out those brackets and then we'll see if we've answered the question correctly.
Would it be x plus 2 in the second bracket or minus 2?
Oh, sorry, it would be minus 2, wouldn't it? Sorry, quite right. Yeah, p is positive 2, but it would be negative 2 inside the bracket. Yes, thank you. Sorry, this is a negative. Sorry, Nelisa, I'm half asleep tonight. Thank goodness for you.
I can understand. This week I've been so drained, like
It's just been a crazy week, hasn't it?
Yeah. I try to take naps during the day, but I can't. Like I could feel my body, like I need to sleep, but I can't.
Yeah.
I have things to do.
Yes, I know, it's terrible. Can you imagine how these poor matrics must be feeling?
Well,
Probably the
It's
same. They
already
also, all they want to
tomorrow.
do is sleep, and they've just got to work.
No, we don't. But we feel like taking a nap, but we end up not taking the nap because we have things to do. Yeah.
Yeah, I think so too, can you see that? I think it's worse your side right now.
Yeah.
Excuse me.
Oh, Aruna. I don't even know what sleep is no more.
Oh, shame, Alrina.
Shame.
You'll get there.
And it will be worth it at the end of the year.
It will. It will. Even when you think you've got nothing left inside you to give, you've still got, yeah, a lot left.
Yeah.
So don't give up. Oh my, you hear your brother snoring through the wall.
Oh, I'm so sorry for that.
Oh, you
That's
have
not
all
my
my
fault.
sympathy in the world. There's nothing I detest more than someone who snores. Okay.
Yeah.
True, can you see, Les? So true. All right, Kashandra, can you please explain, because I don't get the question. Which one, Kashandra? You mean multiplying these brackets out? Is that what you're referring to? Oh, you mean you don't understand that everything was calculated? Okay, maybe Neliswa, can you private message Kashandra and just assist her with that, please? Thank you. I agree, Hope. Was there no last term, Hope? Because at this point over here, we would have our y equals x plus 5. And then here, when we square our binomial, we'd end up with x squared minus 4x plus 4. And then we would end up with y equals, so now, oh, sorry, we don't need the brackets there anymore. So now we're going to multiply the x by every term in the other equations. So it'll give us x cubed minus 4x squared plus 4x plus 5x squared minus 20x plus 20. All right, so now we finally end up with y equals x cubed plus x squared. I agree with you. Minus 16x, I get plus 20 on the end. There we go. Okay, Boyd Shepherd, you do as well. Okay, all right. And there we go. We have showed that B is 1 and C is minus 16 and D is 20. What you absolutely cannot do in this sort of question and in any question in maths where it says show that is you can't use the information that they've given you. They're not asking you to verify. If they were saying to you verify that it's true, then you could sub that information in and get something that they had showed you. But you need to approach questions like this, like you don't even know that that's the answer. Okay, so that's what is expected in this case. All right, is everybody happy with that? Are we ready to move on? Yeah, it's just distribution. Absolutely. Absolutely, Cornelia. That's all it is just distribution. Yeah. We're just multiplying out brackets. Okay. All right, good stuff. Now they want us to calculate the coordinates of P and R. Okay, now I think that you guys can do without me. Well, and Neliswa. P and R, are you happy to try that on your own matrix? Okay, so P and R represent the turning points. So how are you going to find the coordinates at the turning points? There we go. Well done, Mbongeni. Beautifully, beautifully said. Perfect. Okay, so I'm going to hang back here and I'm going to let you guys try this one on your own, okay? And remember, we're working with the graph of g of x. Okay, g of x. Only information you need over here, Kaiser, is this. Okay, so we're calculating the coordinates of P and R. It's the second question. And there's P and R on the graph, okay? No problem. Okay, so Kanisile, you've got some answers there that you're sharing. Good. Has to suggest. I left my answers as improper fractions, Hope, but I'm just going to check if we maybe got the same thing here. Yes. Okay, just maybe it was just a little typo on the computer, Hope, but yes, you're right. Yeah. Okay, lovely. Well done, everybody. Yes, can you see it? Beautiful. Well done, Kulani. You got the first one. Good job. So just in case there's somebody who's a little bit confused, I'm just going to write the answer down myself. what you guys have done here. That's good. Remember, you must show that it's equal to 0. Okay, very, very important. Okay, and then here you would end up factorizing. And of course, that's where your -8/3 or where your x equals 2 comes from. Okay, so theoretically, we actually already know what this answer is before we start, because we knew that p was equal to 2, okay, as the x-intercept. All right, so we also know that it's a turning point. And of course, to work out the others, you've just got to go back and sub into the original. Okay, so easy enough. And make sure that you show those steps. Okay. Okay. Next question.
Ma'am,
Yes.
would we get lower marks if we use the quadratic formula instead of factorizing?
No, Kaiser, not at all. The only thing with the quadratic formula is you've got to show that you've subbed into it. So there is a mark that is awarded on this line here, Kaiser, for factors, or for the quadratic formula. So you can say x equals -2 plus or minus, but you've got to show that you've subbed in. You can't write -b plus or minus b squared minus 4ac. You've got to show that you've subbed in. So let me just show you what you would be writing, although I'm sure you know. All over 2. Okay. So either the mark would be for the factors or for that. Okay, Kaiser, so you must show one or the other.
Okay, thank you, madam.
No problem. Pleasure, pleasure. Okay, so let's go back and have a look at question 9.1.3. Is the graph concave up or concave down at 0 and 20? So in other words, and then we've got to show all our calculations that we've used to be able to determine this answer. So they are saying to us, in this particular case, 0 and 20 is our y-intercept, okay? Is the graph concave up or concave down at that point? What are we going to use to help us with our answer? Quite right. Second derivative, absolutely. Okay, so let's take the second derivative. Good job. Let's take the second derivative. So we've got the first derivative there on the screen, so we can work from here. So taking the first derivative, we end up with 6x plus 2. What would we do now? %, equated to 0. Good, lovely. And after we've equated it to 0, we would solve for x, wouldn't we? What would our answer tell us? What does our answer tell us?
Our answer tells us that it's -3 to positive infinity.
Okay, so that is going so from -3 to positive infinity. What's happening with the graph, Kaiser? I'll go back up again and have a look. -3 to positive infinity. What would the graph be doing? or sorry, negative a third and to positive infinity, what would the graph be doing? It would be concave up or concave down? Okay, but the question, but hang on a second. Yes, Johannes, I agree with you. Yes, Kanisile, I agree with you too. It would be concave up, because what we've done is we've worked out the x coordinates at the point of inflection. Okay, so at the point of inflection, x is equal to -1/3. So any value of x that is smaller than this means that the graph is going to be concave down. Any value of x greater than that one, the graph is now going to be concave up. What is the value of x at this point over here? X is equal to? Yeah, we read from left to right. We certainly do. Okay, so at this point over here, x is equal to 0, isn't it? So that is to the right of x equals -1/3. So therefore, the graph would be concave up. Does that make sense? Okay, no problem. All right, so yes, 0 is larger than -1/3. So it's to the right, and that's going to be the portion of the function where it is now concave up. Cool. Oh, Johannes. Oh, goodness, you guys are very funny. Okay, so let's go on and have a look at the second question. Well, I've actually got a couple. Hang on, where are they? There was this question over here that I wanted to do with you guys. All right, so what if they give us a sort of more difficult application type question like this one? It's only out of 3, but it's just, oh, good. So there's a lot of smiling faces. Just Cornelia is crying. So in number 9.2, if g is a cubic function with g of 3 equals g prime 3 equals 0, what does that even mean? What does that even mean to us? Okay, so the gradient at 3 is 0. Absolutely, so quite right. So what they're telling us here is something that's twofold. We've got an x-intercept that's also a turning point at the point where x is equal to 3. Does that make sense to everybody? Shane Kaiser. Luckily, this is not going to be too bad a sketch. All right, so g of 3 means that when x is equal to 3, y is 0, so that is an x-intercept. And g prime 3 means that the gradient at x equals 3 is 0, so that's why it's also a turning point. What does this mean over here, what I'm highlighting in blue?
Ma'am, is that the y-intercept?
It certainly is, Kaiser. Well done. That is the y-intercept. So the coordinates at the y-intercept are 0 and 27. Yes, Butchepo, quite right. And now comes this bit of information here. So they tell us G double prime X greater than 0. What does that mean? What does G double prime X greater than 0 mean? Absolutely, concave up, quite right. Okay, so the graph is concave up when X is smaller than 3. And this bit over here concave down when X is greater than 3. So that tells us something about the shape. So 3 is an x-intercept that's also a turning point. With the information that they've just given us, they've also told us that the graph is concave up when x is smaller than 3 and concave down when x is greater than 3. So what else is that? What other information are they giving us about 3? It's an x-intercept, it's a turning point, and it's also a point of inflection. Absolutely. Okay, so that means that this is going to be one of those really weird shaped graphs. Okay, so one that looks like, let's draw ourselves a set of axes. Let's just make that a little bit bigger and just pull that down to the side. Okay, because that's the only information that we've got, okay, apart from the fact that it goes through the y-axis where y is equal to 27. So 3 is an x-intercept, a turning point, and a stationary point as well. Okay, sorry, a point of inflection as well. All right, so the graph has got to be concave up, and then it's got to be concave down. Sorry, I haven't drawn that very well. Let me just try that again. Sorry, and I'm going through the axes now. Okay, so it's going to be like that, and then down like this. Okay, concave up, and then concave down. Obviously, it's supposed to be a smooth curve. That over there should be 3, and this over here would be 27. Does that make sense to everybody? Yeah, so Hope, the reason why it's a point of inflection is because of the concavity changing at that point. Okay, so before x was 3, it was concave up, and then when x is greater than 3, it's concave down. So that's why it has to be a point of inflection. Does that make sense, Hope? Quite right, Neliswa. Okay, good stuff. All right, so we've covered that. So let's go and have a look at, and then here it's out of 3 marks. So they'd have to give us a mark, I would say, on having the correct shape, having the correct x and y intercepts, and then that 3, so where x is equal to 3 is going to be a turning point, an x-intercept, and a point of inflection. Okay, that's what they would be looking for. All right, so we've got 25 minutes left. We're going to go and have a look. Now, this is also another sort of slightly more unusual type of question, which I thought would be nice to do with you before tomorrow as well. Okay, so in this situation here, we've been given f of x equals 3x cubed. The first thing that they want us to do is to solve f of x if f of x equals f prime x. Do you think you would know what to do here by yourselves? Okay, good stuff. Lovely. All right, so I'm going to let you do 2.1 on your own. Sorry, 9.1 on your own. Okay, Cassandra, no stress. Okay, what is f prime x? Cassandra. Okay, and Alrina, what's f prime x? The others, you carry on. But Cassandra, Alrina, and Mbongeni, what is f prime x in this situation? It is the first derivative. Okay, so now Mbongeni, you've made a little mistake because you've said that 3 times 3 is 6. 3 times 3 is? There we go. Okay, so f prime x is 9x squared. So if we're solving for this, we are taking 3x cubed and we are making it equal to 9x squared. That's it. Quite right, Cassandra. Okay, off you guys go. Right, and you're going to solve that equation. Okay, good, Alrina. Okay, so we're getting some solutions here. Good stuff. Okay, all right, so let's just go through. I agree with you. Those are the answers that I got when I did this. Just look at my answers. Okay, so quite right. Let's get this down on paper. Okay, so we've got 3x squared equal, 3x cubed equal to 9x squared. So we're going to take, just going to move it all down now. We're going to take them onto the same side. Factorize. And there we go. All right, so either x is 0 or x is 3. Quite right. Excellent. Okay, 9.2. The graphs of f prime, and f double prime all pass through the points 0 and 0. That's it. So we're all getting the same answers. So in 9.2.1, for which of the graphs will 0, 0 be a stationary point? Okay, so which graphs have stationary points? Okay, absolutely. F will have a stationary point because it's a cubic function. So it has to have a stationary point at least. So we know it has to be F because it's a cubic function. What sort of graph is F prime? It's not an inverse in Bongani. F prime is a parabola, quite right. Okay, so F prime is a parabola. Good. What sort of graph is F double prime? That's a Tisha. Okay, so it is a straight line. Do straight lines have turning points or stationary points? No, definitely not. Okay, so F and F curves, so it is possible for them to have turning points or stationary points. So it will be F and F prime only. Okay, but not F double prime. 9.2.2, explain the difference, if any, in the stationary points referred to in question 9.2.1. So what will it be for F and what will it be for F prime? Absolutely, it's a point of inflection. Good, well done. Okay, so for F, it is a point of inflection. For F prime, it is a turning point. There we go. So, Cassandra, you're asking why do you mean why is it a turning point for the one and a point of inflection for the other? Yeah, okay, all right. So if we consider what the graph of f of x equals 3x cubed looks like, what would it look like, Cassandra? I could just draw a quick sketch. So would it be concave down and then concave up, or concave up and then concave down? Any idea? So because this number over here is a positive number, other way around, Cassandra. Okay, so when the number that's in front of the x cubed is a positive number, all right, then the graph is first concave down, concave down, and then concave up. Okay, so concave down is like this, and concave up is like that. Okay, so that will be the number in front of the x cubed. If it's a positive number, this graph will be that shaped. Okay, if the number in front of the x cubed is a negative number, then the graph is going to be shaped like this. Okay, first it will be concave up, and then it will be concave down. Okay, so this graph looks like the green one, right? And because it's the graph of 3x cubed, it means that it has to go through the origin. So it's going to be a bit of a weird shape. It's there, and then it kind of does that. That's what it would look like. Okay, so this point over here, this stationary point is also a point of inflection. As far as the first derivative is concerned, your first derivative is a cubic function. So that's the graph of f prime x equals 9x squared. It's a parabola. So it is going to look like that. Okay, so here at the origin, that is going to be its turning point. Okay, so there we've got a point of inflection, and here we have a turning point. Okay. See how important the shape is to these functions. Okay, shape is so important. There we go. All right, I'm glad you can see that now. At least it's helped you to make some connections. It's a pleasure. It's an absolute pleasure. That's why we're here. Okie dokes. All right, now, so what's nice about this question is that it doesn't, this is why I chose it to do with you, is that it doesn't get you to do all the usual stuff that we already know how to do, like the coordinates at the stationary points or the turning points and the coordinates of the x-intercepts, with stuff we've practiced. Whereas here, these questions are sort of deeper thinking questions where we really need to understand our functions very, very well in order to be able to get these marks. So yeah, that's why I just wanted to do this with you. Okay, question 9.3. Determine the vertical distance between the graphs of f prime and f double prime at x equals 1. Okay, so the vertical distance. So in other words, what they want you to do is they want you to then go and sub in where x was equal to 1. Okay, so the graph of the double prime graph would look like this. It would be a straight line with a positive gradient, and it would go through like that. Okay, so that would be f prime prime. Mind you, I don't know how, can you see the yellow? I don't know if that was the best idea. I'll draw over it in black. Okay, so they want to know the vertical distance between the two functions at the point where x is equal to 1. So it's the y at the top minus the y at the bottom. So first of all, f prime prime x. So if f prime x is the graph of 9x squared, f prime prime x is the graph of 18x. Okay, so the straight line will be above the parabola. Can you see that? The straight line is above the parabola. So that means that the distance is going to be the y at the top. So that's going to be 18 times 1 minus the y at the bottom. So that would be 9 times 1 squared. Does that make sense to everybody? So it would be 9 units. There we go. Does that make sense? Sure, okay, all right. Everybody happy? Yeah, we can. We can. So this question really is about the cubic function and the graph of the first derivative and the graph of the second derivative and how they're all related to one another. Okay, so Tisha, where did we, is it just this? No problem. Okay, so Cornelia and Tisha are just having issues with their Wi-Fi. I'm just going to explain this to them again. Okay, let me just move. over to the side here. Actually, maybe it's better if I just go down. Okay. So we'll draw some axes. And I will try and draw a nice parabola. Oh, yeah. Sorry, that's supposed to be a parabola. It's supposed to be a nice curve here. Sorry, it's quite difficult to draw on this pad of mine. So this is f prime x, and it is the graph of 9x squared. Then we have the graph of f double prime x. It also goes through the origin, up like that. Okay, and where x is equal to 1 is somewhere over here. This is where x would be equal to 1. All right, so they want us to find the difference between the output here and the output there. Okay, so in other words, the vertical distance between the lines, okay, is going to be the value of y at that graph minus the value of y on that graph. So the y at the top minus the y at the bottom. So the straight line is above the parabola. So that's why we are subbing 1 into the second derivative. And it's why we're subbing 1 into the first derivative. Okay, and we would end up with an answer of 9 units. Okay, you get it. All right. Good, I'm glad that makes sense to you. Okay, all right, Cornelia, you happy with that? Okay, so we've got time to do the last question now. Where was it? There we go. Question 9.4. So this is a sort of deeper thinking application type question as well. For which value or values of x is f of x minus the first derivative smaller than 0? They literally want you to sub in. So when they say f of x minus f prime x smaller than 0, they're asking you to take f of x, which is 3x cubed, minus the first derivative, which we know is 9x squared, where for which values of x is that negative? Okay, so what we would have to do here is factorize. We would take out 3x squared, and then we would have x minus 3 is smaller than 0. Now, this is the part where we need to think. What can you say about 3x squared? Is it possible for 3x squared to be smaller than 0? No, it's not. Okay, so for any real value of x, 3x squared is always going to be greater than 0. Does that make sense to everybody? It's always going to be greater than 0. So it's positive. Okay, because it's not possible for us to take a value and square it and then multiply it by 3, and it's not positive. We're almost there. I suppose you could. I mean, what is this going to end up looking like? It's going to be a cubic function, isn't it? All right, so it's going to end up looking like that. All right, so here, for which values is it going to be negative? Oh, sorry, hang on, we've got to work with that bracket there. We would end up with x minus 3 Oh, I'm so silly. X minus 3. Smaller than 0. So x has to be smaller than 3. But because it's not allowed to be equal to 0, x cannot be equal to 0. Okay. So x cannot be 0. Okay, and that was because of the restriction here. Okay, it was smaller than or equal to. Right. So this would be our 3 over here. So as long as x is a number that is smaller than 3, outputs on our function will be negative. We can't include 0 because at 0, output is 0, and then it's, strictly speaking, not negative. Okay. There we go.
Hey, today is quiz day.
Today is quiz day.
Yay. I'm going to post a link on the chat.
Thank you, Neliswa.
My pleasure.
Madam, can you please help me with one question from a past paper, please?
Kaiser, unfortunately this evening I've got to go. I've got to take my daughter somewhere as soon as we finish tonight. I don't know, Neliswa, if you would maybe be able to help Kaiser.
Yeah.
Is that all right?
Yes.
Maybe you can guess if you could. Is that okay, Kaiser?
Yes, ma'am.
Which year? Which year is the question paper from?
It's this year's supplementary exam for maths paper 1.
Okay, 2022.
I'm going to say goodbye and wish you all